Wow! Today on our presentation, we shall be doing linear equations. Please, if you have not watched my video on equations, kindly do that. Else you may not understand this very video. My name is Peter, linear equations. Yeah, linear equations. What do we mean by the expression linear equation or linear equations? Well, linear equation is always in the form ax plus b is equal to 0. This is what we refer to as a linear equation. And in a linear equation, always the solution is always 1. Why is the solution always 1? Well, let me first give you the solution. Now, the solution to this linear equation happens to be x is equal to negative b out of a. Yes, this is the solution to the linear equation. How do you come by that? Well, in my previous presentation, if you remember, I told you that our a and our b are always constants. Are you okay? And the only variable we have happens to be that of the x. Are you okay? So having the constants already, what do? Yes, you just solve for your x. Alright, so this is what we mean by a linear equation. In the form ax plus b is equal to 0, where a and b are always constant. And a must never be equal to 0. A must always be a number, even if it's only 1. Yes. Fine. Now let me take you through some examples of linear equation or equations. Fine. Now we have 3x plus 4 is equal to 0. This is an example of a linear equation. Why? Yes, we see our constant 3, we see our constant 4, and then we have our variable x. So this tells us that this is an example of a linear equation. Okay, we have so many symbols that we can use in writing linear equations. It does not necessarily mean that at all times our variable must be x. Oh no. We can use any other symbol or any other alphabet. Okay, so I can write something like 27p minus 8 is equal to 0. This is also an example of a linear equation. Yes, because my constant happens to be 27 and negative 8. And my variable happens to be what? P. Let me give you another example using k. Okay, so you can write something like k plus 5 is equal to 0. Yes, k plus 5 is also a linear equation. Why? Because anytime you multiply a number by 1, it is still the same number. Which means that whenever you multiply a variable by 1, it is still the same variable. For example, whenever I have a times 1 is equal to a. Yes, so once we have k here, the k here tells us that we have 1 times k. So what is our constant here? Our constant happens to be what? 1. So this is also a linear equation because we have a constant of 1 and then we have a constant of 5. And then our variable happens to be what? K. Yes, so these are few examples of what linear equations are. But how do you solve linear equations? That is going to be our final objective. Yes, solving linear equations. Solving linear equations. Solving linear equations. Ax plus b is equal to 0 with a solution negative b out of a. Well, let's have this example. We have 2x plus 6 is equal to 0. Yes, 2x plus 6 is equal to 0. In my previous video, I explained to you how equation should be solved. Yes, once it is an equation, it means both the left and the right hand side of the equations are the same. So, in solving equations, what do? Anything you do to the left hand side of the equation, you do the same to the right hand side of the equation. Well, here we are after x. So what do? We must first transpose the number 6. And how do you transpose the number 6? You must do something to this number 6 so that 6 here becomes 0. And what do? This is a typical example. 1 minus 1 is equal to 0. So it means if we have 1 here, What do we need? We need negative 1. So if you have 6 here, what do we need? We need negative 6. So you have 2x plus 6 minus 6 is equal to 0. Once you have added negative 6 here, what do you do here? We add negative 6. Okay, so now you have 2x, 6 minus 6 is 0, and then you have 0 minus 6, which happens to be negative 6. So now you have 2x is equal to negative 6. Okay, fine. We are after what? X. So what do? We divide through by what is attached to x. And what do we have attached to x? We have 2 attached to x. So we divide through by what? 2. Okay, so now you have 2x is equal to negative 6. So what do we have? We divide through by 2. 2 goes to itself 1. Yes, and then into 6 3 times. So we have x is equal to negative 3. Yes, we have got our solution. But how do you know that our solution is right? Well, let's check. From the very linear equation, we realize that the solution to the equation happens to be negative b out of a. Let's cross-check something here. Right from this equation. Yes. From this one, we have what? X is equal to negative 6 out of what? 2. Yes. So, that is how it works. A is 2. Then we have our x. And then b is what? 6. And the solution. And then we have our a divided by a. So a is 2 divided by 2. And then since it was last year, with the solution, we're going to have negative, and that is what we have here. So it tells us that we have been able to solve this one. This is the first proof of the solution. Now I'm going to give you another proof to prove that our solution is right. Okay. Now, after solving, we realize that our x happened to be what? Negative 3. How do we know that it is 3? Okay, wherever you see x, you substitute it by what? Negative 3. So now we have 2, and then x, that is negative 3, and then plus 6 is equal to 0. The bracket means you are multiplying. So 2 times negative 3 plus 6 is equal to 0. What is 2 times negative 3? That is negative 6, and then plus 6. And what is negative 6 plus 6? Well, you can turn it this way, 6 minus 6. And what is 6 minus 6? Is 0. So it tells us that our answer, which is negative 3, is right. This is how to solve what? Linear equations. Very good. Let us do another example. It isn't at all times that our solution is going to be just a number. Sometimes we can have the solutions to be in the forms of what? Fractions. So this is an example. We have 5k plus 12 is equal to 0. Yes. So by the transposition, we have 5k plus 12 minus 12 is equal to 0 minus 12. So now we have 5k plus 0 is equal to negative 12. So now we have 5k is equal to negative 12. So now we have 5k is equal to negative 12. Divide through by 5. So now we have k is equal to negative 12 out of what? 5. Yes, because 5 cannot divide out 12. So this is also an example of what? A solution to a linear equation, whereby the solution is not what? A whole number, but rather what? A fraction. Good. Now you realize that from our very first example, our answer happened to be a negative answer. With our second example also, our answer also happened to be a negative answer. But it isn't at all times that solutions to linear equations should have a negative answer. The negative comes because of the nature of the constant b. Because we have positive b. That is why our answers were negative. Okay, now let us check this very example. You realize that the solution changes from a negative answer to a positive answer. This time, I'm going to make the b a negative value. So let's say we have something like 4 and then y minus 24 is equal to 0. Yes. So what do? We must transpose this negative 24. Since it is negative, we must add 24 to make it 0. So we have 4y minus 24 plus 24 is equal to 0 plus 24. Yes. So now we have 4y and then plus 0. Since negative 24 plus 24 is 0, and then we have what? 0 plus 24 is what? 24. Okay. So now we have 4y is equal to what? 24. Yes. So now we have 4y is equal to 24, and then out of 4, we realize that 4 going to itself 1, 1, and then 4 going to itself 1, and then it goes into 24, 4, 5, 20, 4, 6, 24, so we have 6. Yes, so that is it. So our y happens to be what? 6. Beautiful. This happens to be what? The positive answer. Yes, because the nature of the constant b, which happens to be what? Negative. So what I can tell you here is that the nature of the answer depends on the nature of the what? Constant. Well, let us prove to see whether our answer is true. Okay, so where we see y, we substitute with what? 6. So here we have 4 and then what? 6, and then minus 24 gives us 0. So we have 4 6 24, so 24 minus 24 is equal to 0. So it tells us that our answer, positive 6, happens to be right. This is how far I can bring this lesson to its successful end. In my next presentation, I shall be taking you through how to use these linear equations in solving other problems. Thank you.